Hello, physics students. Just answering a couple of questions on the Chapter 5 and 6 practice test that have been asked by students. One is problem number 40. A box of mass 61 kilograms is at rest on a horizontal frictionless surface. A horizontal force F then acts on the box and accelerates it to the right. It is observed that it takes the box 4.5 seconds to travel 48 meters. What is the magnitude of the force? Well, the magnitude of the force, or the sum of the forces, will equal ma. And if this is a box, it's got a gravity, it's got normal force, they cancel each other out. The only real force is this frictionless. The only real force is this other constant force F that's accelerating this thing. So that's not really the only one that matters here. So the sum of those forces in the x direction are the only one we care about. And it's just that force F. That's the only one that's there. So just F equals ma. M is 61. I just got to figure out what A is. If I can figure out what A is, then I will know the magnitude of that force. So I'm going to use what it gives me, 4.5 seconds at 48 to go 48 meters with a constant acceleration. So that's when I'm going to go back to kinematics. A equals A, VF equals AT plus VI. VI here is 0 because it starts at rest. And then XF will equal 1/2 AT squared plus VIT, but that's 0, and plus XI, which we can say is also 0. So I think I know what I need to know here. XF is 48. A is what I'm looking for, and T is 4.5. So now if I just do the arithmetic on that, or the algebra on that to solve for A, I should be able to get A. All right, in my calculator, I got A to be 4.74. Now that I know that, I just put in 4.74 for the acceleration there, and then just multiply the mass times that acceleration, and I get the force to be 289.2, or if I go to two significant figures, I guess that would be 290. And 290 was the correct answer there. The other problem that was asked about was number 42. All right. A block is given a very brief push up a 20-degree frictionless incline to give it an initial speed of 12 meters per second. How far along the surface of the plane does the block slide before coming to rest? Okay, so let's draw a little picture of this. We got this block on this 20-degree incline, and it's given a push, and it's going to go up the incline until it comes to its highest point. And then it's going to start coming back down the incline. It's a frictionless incline, so the only thing that is going to be keeping this block from just continuing to slide up this incline is gravity. Now I'm going to draw a free body diagram where gravity is going to act straight down, and the only other force acting on this thing is the normal force. So this is the force of gravity, right? The force of gravity is like this. The normal force is like this, because the normal force is always perpendicular, right? It's perpendicular to the surface. All right, so that's the force of gravity. Force of gravity is always equal to mg, and this is the normal force. All right, I'm gonna orient my x and y axis like this. That will make things easier. and I have the 20-degree incline, that angle will be present right here in my free body diagram. So now the sum of the forces in the x direction are going to be just the force of gravity. The normal force is not going to have any component in the x direction because it's completely a 90-degree angle, completely a vertical force. Now, I could put it in there with the cosine of 90, but that's going to be 0 anyway, so it's going to cancel it out. So I'm just going to make that a little quicker. It's the force of gravity times cosine of 250. Remember, we always doing in the force, some of the forces in the x direction. I just always have this system where I always do the cosine of the standard angle. So cosine of 250, that's the standard angle, equals MA in the x direction. And FG is just the same thing as MG. Cosine 250 equals M times the acceleration in the x direction. Notice that the two m's can cancel, which is why they were able to just not even give us the mass, because the mass is going to cancel out anyway and not be needed for the answer. So I left out my 0 right here on 250, didn't I? All right, so it's 9.8 cosine 250. That's going to equal my acceleration in the x direction. So let me do that in the calculator. 9.8 times, give me a second here, get my phone calculator to do cosine of 250. I get negative 3.35. Okay. That makes sense that it would be pointing in the negative x direction, right? So, because the acceleration is pointing down the ramp, obviously. All right, now I haven't answered the question yet. How far along the surface does the block slide before coming to rest? From here, you can use different equations to do this, but I'm going to just start here. A equals negative 3.35. VF equals negative 3.35. T plus VI. And XF equals negative 3.35 T squared over 2 plus BIT plus XI. Well, XI can just say is 0. All right, so I think I'm actually going to answer part B first because I'm going to be able to find the time. I need to find the time before I can find the distance in the way that I'm doing it here. So what is the final velocity when it comes to rest? If it's sliding up the inclined plane and then it comes to rest at some point, then that final velocity is 0 at that point. Something's wrong with my computer screen. It's not really working well right here. I'm going to have to kind of fool with it to make it give me a spot to write. So 0 equals negative 3.35 T plus what is the initial velocity? It gives me that initial speed was 12. So then just do a little algebra to get T by itself here. And the time will be 12 divided by 3.35, 3.58. So that should be the answer to, that's almost the answer to part B. It's not quite the answer to part B. It says how much time does it take to return to its starting position? Well, 3.58 is the time it takes to get up the ramp. Then it starts sliding back down the ramp. It's going to be a symmetrical kind of a movement. It's the same amount of time up as back because it's a constant force, constant acceleration the whole time. So just double that. It's 3.58 to get up the ramp, 3.58 to get back down the ramp. So the time is going to equal 2 times 3.58. 7.16. That's the answer to part B. Now back to part A. Let's see here. XF is what I'm looking for. Negative 3.35 over 2. T is what I know now, 3.58 squared, plus VI, which is 12. times t, which is 3.58. And now I can just do my arithmetic here to get that final position. All right, negative 3.35 over 2 times 3.58 squared plus 12 times 3.58. I get 21.49 to be the answer to part A. And those are the correct answers. All right, good luck on those problems.